Ready? Hi guys. Hello everyone. I think all are doing good. So as I said, we'll be keep giving sessions. I'll be keep giving sessions. So yeah, I'm now here with another session on machines. Like in machines PYQs. First of all, confirm guys whether audio and video is clear or not. Hi Praveen. Hi Vikram. Hi. Nice. Hi Rahul. Hi Yadav. Okay, nice. Thank you Kumar for confirming. Yes. Now I think you must be ready with the calculators and all. Okay, not calculators actually, because theoretical aspects only. Because more you answer the questions. You can see the list over here. I cannot read this list, because it's in. For me, it will appear reverse. Okay, for the camera it looks good, but for me it appears reverse. So more responses, you'll be getting more rewards. Okay, get ready. Let's get started. Let's get started with the session. Are you launching any course? We already launched courses, but no extra launches. Okay, we're not launching any extra courses. Yeah. Before I start the session, all of you share this video, like the video, share this video, and let me tell you a point here. The point is, I will do the next session, continuation to this session, immediately after this video reaches 500 likes. If I don't get likes, 500 likes, until I get 500 likes, there won't be next live session. Yes, I mean it. I'm serious on that. I'll stick to it. Okay. We need 500 likes. Then only I'll continue the session. Till then, I'll be waiting and I'll be waiting. Not a problem. So it's your responsibility. My responsibility I'm doing. It's your responsibility to, like and share. Okay. Yes. Ready. Great. Let's get started then. So we'll have a timer. I think let me show you the timer and all. Yeah. Timer is there. You can check here, right? Timer is there. So I'll give time for every question. You will get a time. I'm guaranteeing, sir, you will get 500 likes. See, you'll have to hit the like. Okay. How are you? I'm good. How are you all? Okay. Now. Without further ado, let's get into the session. Okay. Electrical machines, MCQs, PS Bhimbra, Part 5. Okay, yeah. You can see me, right? Anyways, once we go to the actual question, you can see me better. I think I'll lift my head up. Okay. So are you ready for that first question? First question, are you ready? Let's begin with the first question. You'll have first question on the screen. On the screen, you'll have first question. I think it's a little small. Let me make it bigger. Yeah. So we got 1 minute time for this question. Timer is TikTok running. Timer is running. You have to answer the question. Yeah. I think it's better. I'll watch. मैं मोबाइल में चेक कर लेता हूँ, यही सही होगा. Wow, we already got the answers. Nice. Whether it is good or correct or wrong, some people are responding first, but second thing should be correct. Okay, a lot of good answers. Yeah. 18 seconds more. Like the video, all of you. We get how many likes? Once we get 500 likes, then our next session. Otherwise, no next session. Till then, no next session. Yes. Time's up. Did you hear the sound? Timer sound. Did you hear that? Time's up sound. Most of the people, I'm getting answer 4, 4, 4, 4, 4, 4, 4. Very good. 4 is absolutely right. 4 is absolutely right. Let's check it out. Let's check it out. Yes. So it is given two 8-pole DC machines. Two 8-pole DC machines are there. And identical armatures. Armatures are identically wound. Okay. One with lap wound and another one is wave winding. One is lap winding, another one is wave winding. This is what, this question indirectly we solved in different parts. Okay. One important key aspect here is, lap winding. Tell me, lap winding and wave winding, you match it. High voltage and low current, low voltage and high current. You match it. What is correct? Correct matching? Do the correct matching. Yes. Good. Perfect match. Lap winding is for low voltage. Wave winding is for high voltage. Why? In case of wave winding, tell me number of parallel paths. How many number of parallel paths will be there? Wow, good. How many number of parallel paths in case of lap winding? Yeah. For lap winding, number of parallel paths, A is equal to how much? And for wave winding? No, not 2. Yes, Rahul is correct. Number of parallel paths is equal to number of poles in case of lap. In case of wave, it is 2. In case of wave, it is 2. More number of parallel paths. What does more number of parallel paths will give? More parallel paths means more current. Every path will drive some current. Okay. All paths will have same voltage. Every path will drive some current. Okay. So when you have more paths in parallel, it's like water pipe. Okay. Whenever it is a current, you always think it as water flow in a pipe. Okay. 4 pipes are running parallelly and they're clubbed at one point, you'll get more current. Okay. So lap winding, high current or more current, you can say. As more number of parallel paths are there, voltage will be reduced because number of conductors will be same for both the machines. Okay, number of conductors are same for both the machines. So as parallel paths are more, number of conductors Z1, wave winding and Z lap winding, if I take, both conductors are same. Okay, so tell me number of, oops, there is some problem I think. दिक्कत हो रहा है कुछ? Okay. What I was saying? Yeah, number of conductors are same, but number of parallel paths are different. So this slight issue, I think. Yeah. So voltage depends on number of parallel paths, number of conductors per parallel path, Z by A. Okay. Here also Z by A. Okay. So as A is less, this is what the voltage. This is what the voltage relation. Okay, proportional relation, not exactly equal to, I should say. It's a voltage relation. As A is less for wave winding, voltage will be more for wave winding. Okay, so answer is 4. Okay, good. Yes. Like the video, all of you like the video, like the session. Next question. Yes, we're going to the next question. Timer, let me start the timer. Let me start this timer. Timer is running. Just got another minute. Next question, please. Okay. Who is having an issue? Lab is having more current. Great. Nice. Wow. In the middle, there will be a question. For that question, you get a reward. Okay, there will be a question. If you answer the question in time, then you'll get a reward. Stick to that question. Okay. That's gonna be reward time. You got 10 seconds more almost. If the applied voltage to DC machine is 230 volts, then the back EMF for the maximum power, I think 1 minute is more for this. Yes, time's up. Who is saying answer is 4? Prithvi? How come answer is 4? I think you are applying formula reverse, Prithvi. Okay. Formula is, yes, Rahul is given correctly and Upendra and encyclopedia, of course. He's after all encyclopedia. He must be having complete knowledge. So that's why he's an encyclopedia. Yeah. Is it dear encyclopedia? Yeah. You're absolutely correct. The analysis also, all of it done very nicely. Analysis also you have given nicely. So what's that? At maximum power transfer condition, EB is equal to V by 2. Okay. So 230 by 2 is 115. Now, can you tell me, at that EB value, it is giving maximum power. It is delivering maximum power. Then, why don't you operate at that particular point? Why don't you operate? We can always operate at the maximum power developed point, right? That's always good to operate the machine at maximum power developed case. Okay, that's a point where you'll get a maximum power. Then why don't you operate all the time at that point? Yeah, that's a question from my side. Yes, lovely dear Raghava. Very quick and instant response. Let's see what others had to say about it. No others. Nobody's saying anything else. Only Sai knows that point. No one else. Come on. Yeah. High voltage drop might high voltage drop might come across. High voltage drop. Okay. Any other answers? Any other thoughts? High voltage drop might come across. Iron loss is equal to copper losses. Equal to copper losses. High current in the winding. See, in maximum power transfer theorem, tell me maximum power transfer theorem. Don't think about the machines and all. If you just talk about a maximum power transfer theorem, tell me it's just same as maximum power transfer theorem. Okay. Tell me what is maximum power transfer theorem? I think let me explain. Maximum power transfer theorem, MPT. Okay, maximum power transfer theorem, right? So MPTT. Let me take MPTT. I think screen is not there. क्या कर रहे भाई? Screen को change करना है. Okay. So MPTT, maximum power transfer theorem. So what is that? If we have a source, let me talk in terms of DC. If you have a system like this is a load, and you have a source, this is a voltage, voltage and source resistance. If these two are equal, RS is equal to RL, then you will have maximum power transfer. Exactly. Now tell me, let us take at the maximum power condition, some current 5 ampere is flowing in this. How much current is flowing? 5 ampere current is flowing in the circuit during maximum power transfer case. Means at the load, how much power is delivered at the load? How much is the power? Power delivered for the load is I square into RL. Okay, let us take this amount is some 100 watts maybe. I'm just taking some number, 100 watts. Okay, maybe 1000 watts. Now tell me, under maximum power transfer case, yes, I want answer from you. What is the power at this resistance? Power consumed by this source resistance is how much? Yep. I'm asking power consumed at the source is how much? I have given here, this is 100 watt. If this is 100 watt, how much will be this? Yes, exactly 100 watts. Means the amount of power which we are giving to the load, the same amount is being wasted in the resistance. Means power source, the battery what we have here, that has to drive this one as well as this one, that has to deliver the power to this one as well as this one, both, and out of which this is the only useful thing, this is lost, internal resistance, right? So 50% of power is wasted. 50% of the power is wasted. So efficiency is 50%. Okay, that's the reason why we never operate the machine at maximum power transfer case. Yes, now this one, let me give maybe 2 minutes to this because you need to think a little about it. Okay, it's difficult, but you need to put your thoughts on this. Yes. Yeah, we want how many likes for the next session? Next session, how many likes? 500 likes will come with the next session, next amazing session. Okay. So if you don't like it, you're not going to get the next session. I hope by next week, by next Sunday, if we reach 500, then yeah, we'll definitely go. Yeah, just think first. Don't be in a rush to answer the question. You need to think a little. It's not that easy. You got 2 minutes time, right? Why you are in a rush? अच्छा इसका कलर चेंज नहीं हो गया यूजर का नाम जो ब्लू कलर में आ रहा दिख नहीं रहा नेक्स्ट टाइम चेंज करता हूँ In DC machine, voltage regulation is proportional to speed. Wow, that's a good statement. That's a good statement. So speed is more. Shiva Ganesh, you made a good point. Remains same, DC motor has a constant speed. DC shunt motor has a constant speed. DC shunt, see, it's a crazy point. DC shunt motor is a constant speed motor. Yeah, time's up. Can somebody answer this point who has said, of course, he's absolutely right. I'm not saying he's wrong. He's absolutely right. When I is saying a DC motor has a constant speed, that's absolutely true. But under what is the condition for that? I mean, under what case we talk about a constant speed? With respect to the load. When load is changing, when I'm changing the load, you won't get much of speed variations. Okay, almost a constant speed. But if I purposefully change the speed, obviously its speed will change, because speed control of a DC shunt motor can happen, right? Yes or no? Speed control method, armature control method, that method, this method, wall linear method. There are many methods what we do to control the speed. Purposefully we're doing it. So it is said the speed has been increased by any method. I increase the speed. Okay, it's a generator, by the way. Okay, it's not a motor, it's a generator. As it is a generator, I will rotate with my hand. I'm rotating with the higher speed, so it will rotate obviously. If it is a DC motor also, I can change the speed. That's all different story altogether. Yeah. Now, to answer straight to the question, when I has given a statement, all of you make note of that statement. In a DC machine, regulation is proportional to the speed. That's a good statement. You can take that statement. Now, let me explain. That statement what he has given. Let me give the analysis for the statement what Vinay has given. Okay. All of you say. Thanks to from my side, I'm giving. From on your behalf, I'm saying thank you, Vinay, for giving such a beautiful statement. Okay, so let me now explain the situation. See, DC shunt motor has a full load voltage regulation at 10% at rated speed. Okay, we're having two cases here. Okay, let's take case 1. In case 1, speed is how much? 1000 RPM. In case 2, speed is 1250 RPM. Okay. And now, as speed is increasing, obviously the EMF induced will increase. E0 is increasing. Here also. Now tell me, will there be a saturation effect with respect to speed? With respect to speed, there is no saturation effect on the no load EMF. It's a no load EMF. No load EMF will proportionally change because flux will set into saturation. But with the speed, same flux is there. I'm not changing the flux. Flux is same. So as speed has increased, no load EMF will increase automatically because E is proportional to generated EMF Eg is proportional to N. There is no saturation term coming into this. Okay, so E0 will increase from, let's take for this case, E0 is for the sake of simplicity, I'm taking 100 volts. Okay, so for this case, as speed has increased by almost 1/4 or 25%, this will also increase to 125. Speed and EMF will proportionally increase. Okay, E0 value is increased. Now, terminal voltage, because of the saturation which is setting in, because current is flowing, because of the saturation which is setting in, obviously here, let me take terminal voltage because of the drops, because the voltage drop and all, there will be definitely some less voltage. Let me consider it as 90 volts. Let me consider this one as 90 volts. And here terminal voltage will be, it won't be proportional. Here 90 into, it should be if there is no saturation effect and all, it should be proportional, that is 90 into 1250 by 1000. It should also increase by 25%, but because of the saturation condition, this will be less than this value. Okay, as it is less than this value, then E0 minus Vt by Vt will be more. Okay, because this difference is more and this is less, so this will be more obviously. Okay, so in simple short, when I have set the point, so you can take that point. Okay, you can take that point in case of a DC machine, voltage regulation and speed relation. Yeah. Now here with the next question. Timer is set to 1 minute. Enough? 1 minute is enough. Oh, I didn't give the answer for the previous one. More. It will be more than 10%, not less than 10% for the previous one. Okay. Answer is 1. Answer is 1. Kaushik Bose, you're right. Upendra, I think you got a point, right? $15 seconds more. Balaji is 3. Full to entertainment is A. Okay. Okay. People are giving answers, but I think they're giving randomly maybe. Are you guys giving randomly, or you're just thinking about it and giving it? You're thinking? This is an interesting piece. This is an interesting piece of question. Yeah, now coming to my answer. Let me answer this. Let me answer to this. Two DC machines, A and B, using same conductor material have armature circuit resistance of 0.4 ohm and 1.2 ohm respectively. Okay, A and B, they're using same conductor material. Same conductor material means what? They will have same resistance per length. Resistance per unit length, I mean. Okay, because material is same, so resistance value is not going to change. Wow, but the conductor resistance is not different, that's same, but armature circuit resistance is different. For A machine and for B machine, for A it is 0.4 ohm, for B it is 1.2 ohm. How come this can happen? We have same conductor means same resistance per unit length. If that is the case, then how come you are having different resistances for the machines? Just tell me, can somebody tell me? How come resistance is different if the conductor length, if the conductor diameter, if the conductor resistivity, material, everything is same? How come you have a different resistances? Yeah? Yes. Yes. More length? No, it is not said more length anywhere. Per unit length, I'm asking per unit length if we talk about, that's same for both the cases. Okay. Area may be different. More area. See here, when you're comparing two machines, definitely area, everything will be same. The point is, you're having more resistance here means what? You are having, suppose there is one point, I think from networks, all of you must be aware of the networks. In series, resistance will increase. In series, resistance will increase. In parallel, resistance will decrease. When you connect two resistances in parallel, any two resistances in parallel, the resultant resistance will reduce. Okay, means you're having here less resistance means what? You have more parallel paths. Okay, you're having here more parallel paths. Here you're having less parallel paths. Okay, you're having more parallel paths, you're having less parallel paths. Now, as this is having more parallel paths, this will be for the same voltage because parallel paths are more for machine A. For machine A, parallel paths are more. As parallel paths are more, to have the same voltage obviously require more number of conductors. Because the same logic which I said earlier in the previous lecture, previous questions, I think, not this, the first question, I think. Yeah, this question. So from this, same logic applies here also. Okay, so for the same voltage, you have to have more number of conductors. Obviously, you're using more number of conductors overall in the machine for the same voltage, so machine size will be a little bigger definitely. Okay, so answer is A for this. Answer is, sorry, answer is A is bigger than B, means answer is 2. Okay, inversely proportional to area of cross section, number of parallel paths. I think you now got it. For the previous question, what was the answer? For the previous question, more than 10%. Okay. I think before we go to the next question, you tell me, do you have any questions? Do you have any doubts or something in the discussion so far what we had? Yeah? Give it in the comment, give it in the chat, give it in the chat. Like, 500 likes, next session. Okay? And MATLAB, are you guys, do you need MATLAB Simulink, that, complete workshop kind of thing we want to conduct? We want to give complete MATLAB demonstration we want to give. I told you 100, you will get the next videos on that. No doubts. Okay, great. Great. So if you want MATLAB, then you need to share that MATLAB video. Okay, more the people joins, it will be more encouraging. It's simple as that. We're putting all these efforts. You guys are not really sharing it and hitting like. Okay, then how will we get energy? Your like, simple like will give us a good energy, not just to me, to entire team. Okay. Okay, now let's go to the next question. Yes, let me zoom in a bit. Yeah, 1 minute is enough for this. Yeah, now I'll leave the screen so that distraction, are you finding any distraction because of me? I'll just come out of it. Yeah, people are saying, sir, we want ETAP video, that video, we want, everybody want all the videos, but you're not, that you're not continuing that legacy. I mean, you're not passing on to your friends. Okay. If you don't, then how do you think we'll be doing it? If more people are, if the views are encouraging, then it's going to be interesting for us also, right? Otherwise, why would we do that? Yes, time's up. Time's up. Time's up. 4, 4, 4. Wow. This question, every one of you got 4. Not even a single diversion. I think it's a simple question. Yes, it is a simple question. A 10 kilowatt 230 volt DC shunt machine has 4 terminals brought out through 4 leads. For this machine, obviously, let's talk about area of cross section. Area of cross section of series field winding is number 1. Area of cross section of shunt field winding is number 2. Area of cross section of armature winding is number 3. Okay. Now tell me, in the ascending order, thickness, cross sectional area means what? Obviously thickness of the conductor cross sectional area. Out of all these 3, which one is having the highest cross sectional area? Yes, my question is complete. Give me the order for this. 3, 2, 1, 1, 2, 3, 2, 3, 1, 1, sequence. 1, 2, 1, 3, 2. Which sequence is correct? Of course, this question. That's right. You're right. But you got a new question now. The question now is, this is sequence I'm giving. Now, tell me 1, 2, 3 or 3, 2, 1 cross-sectional area, which one is having 1, 3, 2. Shiva has answered 1, 3, 2. Okay. Any other? Sir, education channels very more type to get popular, but only other vast tech channels getting more subscribers as soon as possible. Why, tell me? It's because you students, guys, I think you're not active maybe. Others are active, you students are not active, my students are not active, I think. That's the reason why our students are not active in sharing the educational content. All the bloody crap content you guys love to share among your friends, isn't it? Because if you share any educational video to your friend will start saying, "Arey ya, kya ho gaya? Padh raha hai, ye padh raha hai, wo padh raha hai." By thinking you're afraid. See, being a student, you're afraid to learn. You're afraid to share the educational content. What a bloody shame. Okay. Yes, 132. 312? Yeah. Definitely, this is having highest cross-sectional area. Series winding is having highest cross-sectional area. Okay. Highest cross-sectional area. This is highest. Okay. And the shunt winding is having lowest cross-sectional area. This is in the middle. Okay. This is in the middle. In the ascending order, if I had to say in the ascending order, I told you in the ascending order or descending order? In the ascending order, right? If it is in the ascending order, then it is 2, 3, 1. Who answered 2, 3, 1? What the heck? Not even a single answer 2, 3, 1. If I take it, if you understood it as a descending order, then it is 1, 3, 2. Yeah, Vinay has answered it correctly. If you consider it that way, okay? If you consider it that way, Vinay is correct. But now here question comes, nobody, wow, that's pretty bad. Yeah, guys, if you have to have a good fundamental basics, immediately after this live session, you go to PiSquare, website, which is given in the link is given in the description. Take a free trial course. It's a free trial, right? So take a free trial course. You'll get all the fundamentals with very good animations, with experiments. We've done the fundament that trial course also. I mean, every course, trial course, obviously paid course, every course is very well explained with the demonstrations and all. So try taking trial course, then you'll have a good fundamentals will be strong for you. Okay. So once the fundamentals are strong, you can learn on your own if you want. Okay. Anyways. Now the question obviously one would have, sir, armature current flowing through the armature and current flowing through the series field winding, both currents are same. If both currents are same, then how come cross-sectional area is high for this and cross-sectional area is little less for this? Can somebody answer to this question? Can somebody answer to this question? I am saying sequence is 2, 3, 1 is a sequence, right? Now my point is, if armature and series field winding both are connected in series, if current flowing in the armature is 10 amperes, series field is all having same 10 ampere, then how come armature is having less area of cross section and series field is having more area of cross section? Yeah, tell me. Buddy, at least attempts, any attempts you're doing, or you're not putting your attempts also? Sir asked descending order. Okay, if it is a descending order, anything. Yeah. Why you guys are not responding? Means you don't know that. Okay, let me give you that point. The reason is, in case of, see the point. Let me draw the structure for you. The structure is as follows. Let me draw series field winding. We have series field winding like this. And armature winding will have parallel paths with it. Armature winding will have parallel paths. Let us take, at least it will have 2 parallel paths, because minimum number of poles are 2, at least it will have 2 parallel paths. Means if current flowing here is 10 ampere, then the current flowing in each path is 5 ampere, which means armature current is 10 ampere, which means in every conductor, in each conductor of the armature, how much current is flowing? 5 ampere is flowing. Okay, but in the series field winding, no such parallel paths. Complete 10 amperes will flow in the series field winding. So definitely the current carried by the conductor of series field winding is comparatively very high compared to this armature. So this is having more cross-section area. I hope you got the logic now. So this is a sequence. Now to answer this question, yes, I think most of you answered correctly. Armature winding has thick leads, whereas field winding has thin leads. You're absolutely right. Okay, let's move to the next question. Yeah, the one who answered this correctly in 1 minute, the one who answered this correctly, you will get a coupon. You'll get a coupon. Discount coupon you will get if you answer this question correctly. This simple question. You want me to zoom in? Create more flux with less turns? Who said, Ganesh? That's not true. You have 10 seconds more. Machine B. Time's up. Time's up. Yeah. Kaushik. Can you just briefly type the logic for your answer? What do you think? Why you're thinking that's answer? Can you just briefly type? That makes more sense. Anyways, time's up. Yeah. Type briefly why you're thinking your answer. Okay, what are the answer? You might be thinking any answer which is correct, but what's the explanation? Just brief it. I think my eyes are becoming red all the time. Whoever looks at my eyes, he's saying your eyes are too red. So so please provide videos on special machines and special diodes. Special machines and special diodes. Let's see the possibility. Easy to operate horizontal motors than vertical. See, it is not said in the questions. In the question, it is not said complete motor. It is said main field axis. I mean, case 1, in case of case 1, armature, magnetic poles are placed like this. Okay. In another machine, in case 2, they're placed like this. Now, which one is a better case? Which one is better? That's what the question. Yeah. The better one is the one with horizontal axis. The one with the horizontal one. Okay. Why? Why? Because sorry guys, there is some problem. Yeah, Bose is saying horizontal because easily carry. It's not about carrying. In case of this, you will have field windings, you can place it easily. Field windings, you can place it easily. But the other case, you'll have to put the field winding. There is an issue of a stability, machine construction wise, you'll have issue of the stability in case of vertical design, field windings. Whenever you got to have this, you got to choose between these two, obviously you'll choose this one. Why? Because it is more stable mechanically compared to the vertical structure. Okay, field axis we're talking about. We're talking about a field axis, okay, magnetic field axis. Gravity, yes, field winding, it will field winding will have some unbalance. Yes, absolutely, gravity is the only issue. Otherwise, if there is no gravity, horizontal and vertical, how does it matter? All right. Okay. So machine A is preferable, okay, because it is horizontal. Shiva has answered correctly. Shiva, coupon code. You just WhatsApp us. We'll give you an exclusive coupon code for you. Okay, and you can get the machines course at a very less price. Those who have joined the session, for you also you can take the coupon. Okay, you can take the coupon worth 50%. Okay, 50% discount if somebody want to take the course. Those who are watching the video now, they can make use of this coupon only for 5 people. Only for first 5 people this coupon code will be available. Okay, the coupon code is, okay, today is friendship day, right? What will the coupon code? PI2 friend. What's that? PI2 friend is a coupon code. Okay, anyways, it will be activated immediately once the live is over. It will be activated. You don't have to remember the coupon code. Coupon code will be automatically applied. Maybe at 9 o'clock, the coupon code will be active. What's the coupon for 50%? PI2 friend, FRND. Now, what is your job? What you should do now? You should definitely like the video and share it with your friends. When will I come with a new video? Don't keep asking me, sir, next video. The moment it reaches 500 likes, immediately you get a next video. Okay? Or else 100 shares, anything. Either 100 shares or every time 100 shares, definitely we'll post a new video. 500 likes, yes, that is also new video. Okay? That's it, I think. Let me end this session. We'll discuss some interesting questions. You have participated very nice. If I'm not wrong, you're a little bit dull, sir. If I'm not wrong, you're a little bit dull. I'm a little bit dull. May not be wrong. I may be dull. Who knows? My team people will say better, I think. MNA, okay. That's it. Let me end the session. Today's session here. Thank you all for joining me. Okay. Have a good time. See you in the next session. Okay. Bye-bye.